You are listening to KSJ Podcast. This is a short, crisp, concise, exam oriented, edited editorial for civil services aspirants. In this podcast, we are going to talk about the Perseverance mission on Mars. The source for the content is Melissa Rice's article for the Deccan Herald. In the short time since NASA's Perseverance rover landed in Mars's Jezero crater on 18th of February 2021, it's already made history. At the moment, Mars and the Earth are on opposite sides of the Sun, and the two planets cannot communicate with each other. After working non-stop for the past 216 Martian days, the science teams are taking the first real break since the mission started. We are two members of the Perseverance team, and with the rover hunkered down for the 20 days of conjunction, it is the perfect time to step back and reflect on the mission thus far. Perseverance has tested out all of its engineering capabilities, driven 1.6 miles over rough terrain, and taken tens of thousands of photos with its 19 cameras. Of all these incredible successes, there are three major milestones that we are particularly excited about: collecting the first rock core samples, flying the Ingenuity helicopter, and publishing our first scientific results about the Jezero crater delta. One of Perseverance's primary objectives is to use its sample caching system to extract small rock cores, roughly the size of dry erase markers, and seal them in special sample tubes. A future mission will then pick them up and bring them on a long interplanetary journey back to Earth. For Perseverance's first drilling attempt in August, our team picked a nice flat rock that was easy to access with a drill. After 6 days of assessing the bedrock and finally drilling into it, we were thrilled to see a hole in the ground and get confirmation that the sample tube had sealed successfully. However, the next day, the rover sent photos of the inside of the tube, and we saw it was actually empty. Some of Mars's atmosphere is trapped inside and will be useful to study, but it's not what the team was hoping for. Ultimately, our team concluded that the rock itself was much softer than expected and it was completely pulverized during the act of drilling. 3 weeks and 1,800 feet later, we came across some promising looking rocks protruding up above the red surface. This suggested that the rocks were harder and therefore easier to take a sample of. This time, Perseverance successfully extracted and stored two core samples from the grayish, wind polished rock. After collecting up to a few dozen more, it will drop the samples at a safe and easily accessible location on Mars's surface. NASA's Mars Sample Return mission, which is currently in development, will pick up the sample tubes in the late 2020s and bring them home. But scientists don't have to wait that long to learn about the rocks. At both sites, Perseverance used the Sherlock and Pixel spectrometers on its arm to measure the composition of the rocks. We found crystalline minerals that suggest the rocks formed in a basaltic lava flow, as well as salt minerals that could be evidence of ancient groundwater. Perseverance may be a long way from Earth, but it has a sidekick. The Ingenuity helicopter detached from the rover shortly after they landed on Mars and became the first craft to fly in the atmosphere of another planet. Ingenuity is solar powered, weighs 4 pounds, and its main body is roughly the size of a grapefruit. On 19th of April 2021, the helicopter took its first flight, hovering 10 feet above the ground for 39 seconds before coming straight down. This short hop showed that its long blades could generate enough lift to allow flight in Mars's thin air. The next flights tested the helicopter's ability to move horizontally, and it covered longer distances each time, traveling as much as 2,050 feet in its farthest trip to date. Ingenuity has now flown 13 times and has captured detailed photos of the ground to scout out the rough terrain ahead of Perseverance. These images are helping the team decide how to navigate around obstacles on the way toward the rover's eventual destination, a large delta in Jezero crater. For a long time, potentially millions of years, a river flowed into a lake that filled Jezero crater. This river slowly deposited the tilted layers of sediment we see in the cliffs of the delta. Later on, the river became mostly dry except for a few big flooding events. These events had enough energy to carry big rocks down the river channel and deposit them on top of the older sediment. These are the boulders we see atop the cliffs now. Since then, the climate has been arid and winds have slowly been eroding away the rock. Confirming that there was a lake in Jezero crater is the first major science result of the mission. In the coming year, Perseverance will drive up to the top of the delta, studying the rock layers in microscopic detail along the way and collecting many samples. When those samples eventually make their way to Earth, we will learn if they contain signs of microbial life that may once have thrived in this ancient lake on Mars. That's it for this podcast. Thank you so much for listening. To join KSG India courses and to crack the ICE exam, visit ksgindia.com. You can also get a PDF of this podcast on ksgindia.com.